All right, welcome back, folks. So far this year, we've talked a lot about linear equations or linear functions. Just a quick reminder that a function is just a word for depends on. So for example, you might say Mr. Dudek's weight is a function of how much he exercises. Just a quick reminder. All right, we're going to kind of shift our focus now to nonlinear functions. That is, functions that do not form straight lines. One example of nonlinear functions are quadratic functions. These are functions in which the input value is squared. So, for example, you've got on your notes there 2 columns. If you notice in your quadratic functions over here on the left, in all 3 quadratic functions, you've got a squared value. Okay? Your input value, the x, is squared in all 3 of those. If you remember, our linear equations over here, which we've worked with all year, those things never have a squared value. The x is only raised to the first power. Okay, so that's the difference. The quadratic functions are squared. The linear functions are to the first power. You might also run into what we call a cubic function. And if you can't guess, that's where our x value is cubed. Now, the question is, how do we graph a quadratic function and what will it look like? We graph these things in the same way that we would graph a linear function. So if you remember way back when, we started by making our xy table. So for the function y equals 2x squared, make a table with integer values of x from -2 to 2. So I'll start by doing that. Then it says graph the function. You can't graph a function without ordered pairs. So that's what we're trying to create here. Some ordered pairs that lie right there on our function. So if we plug in -2, we'll get y equals 2 times -2 squared. That's 4 times 2 is 8. And you can plug in -1. And here we see that's 1 and that's 2. So there you see how to plug in our values. And you can all do that on your own if you don't believe me. Now I've got my ordered pairs, and let's graph them. -2, 1, 2, 3, 4, 5, 6, 7, 8. -1, 2, 0, 0, 1, 2, and 2, 8. Now if you wanted to, you could find smaller values than -3 for x and larger values than +3. And our shape is going to look something like a U. Okay, make sure to put your arrows on the end here because this function continues on. So you might wonder how I knew that this was going to be some sort of U shape. I could have told you that right off the bat. The thing is, this U shape right here, first of all, we call it a parabola. And I can tell you that any time you have a quadratic function, your graph is always going to be in some sort of U shape or some sort of parabola. It may be flipped over so that your U is upside down, or it may be right side up, but it may be shifted, but it's always going to be a U. This is because quadratics, they're almost always going to represent or model such things as trajectory of moving objects, or predicting whether your company is going to have a profit gain or a loss. And if you think about the trajectory of a moving object, okay, that's the angle at which it goes up. So if Mr. Dudek throws a baseball, it's going to start by going up, 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 up. but gravity is going to pull it down at some point. So it can't just continually increase like our linear equations do. The height of my ball is not going to continually increase. At some point it's going to fall. Therefore, you're going to end up with some sort of parabola. Oh, I'm sorry, I didn't realize that you couldn't see the bottom of my paper here. That is how you spell parabola. Parabola is this U shape that we see formed by our function. Okay, now to our backside. Looks like you can pretty much see everything there. All right, so how do we use these graphs to solve actual problems? The function a equals 10x minus x squared, where x is the width in yards, gives the area A of a goat pen in square yards. Please graph the function and then use the graph to find the width that gives the greatest area for the goat pen. Now there's something to note here. Before, when we worked with linear functions and we made our xy table, we usually only did 3 or 4 ordered pairs. Okay? I'm going to show you what happens if you do that when working with quadratics. Sometimes you don't get the entire graph. So here's what I mean. If we're going to graph this, let's do it. So let's plug in 0 into our function. Guess what? You're just going to get a area, or what we call our y. We're going to get 0. Now let's plug in 1, and we're going to get area equals 10 times 1 minus 1 squared. So that is 10 minus 1. That is going to be 9. 2 is going to be 16. 3 is going to be 21. Now let's try graphing these points here. So 0, 0, I don't know, 1, 9 is something like that. 2, 16 is going to be something like that. 321 is going to be something like that. Everybody's thinking, Mr. Dudek, that looks like a straight line. Well, guess what? I already told you that a quadratic function is always going to have a parabola shape. So guess what? We don't have the entire graph here. We only have part of it. So even though we think we've graphed 4 points, that's got to be enough. I can draw a straight line. Since this is a quadratic function, we know we're not done making this graph because we don't see our parabola yet. So we need to add more points. So I'm going to add 4, 5, and 6 here. Let's try by plugging in 4. Our area is equal to 10 times 4 minus 4 squared. What is that? 40 minus 16 is 24. Plug in 5, it's going to give us 25. Plug in 6, it's also going to give us 24. Now let's see what happens. 424, something like that. 525 is something like that. 624 is something like that. Oh, look at that. Looks like we already reached our maximum height here. Now our y values are going down again, which means we can draw our parabola, add our arrows, and we can say that this right here is probably our maximum. Okay? Now that I have my parabolic shape, I don't have to add any more points if I don't want to, and I can draw my shape. Now, it says use the graph to find the width that gives the greatest area for the goat pen. Well, what width here, since it's labeled on my x-axis, corresponds to the largest area for the goat pen? And you might be thinking, Mr. Dudek, that's a stupid question. It's right there. It's the highest point, the one that matches up with 25. Therefore, the width that gives the largest area is 5 yards. Or you might say the point 525 appears to be the highest point on the graph. So the width of 5 yards gives us the greatest area. Now, for tomorrow, please have questions 1 and 2 answered, and come in ready for the warm-up with any other questions regarding this video. I'll see you tomorrow.